Hi Pre-Calc. Today we are going to talk about some basic trig identities. Before we start, we're going to go through and remind ourselves of some information we did earlier this year. So let's recall. First of all, remind ourselves that tangent of alpha equals sine alpha over cosine alpha. We can also remind ourselves that cotangent equals cosine over sine. Secant equals 1 over the cosine, and cosecant equals 1 over sine alpha. From here, we can do problems, or I could say express in terms of sine and cosine and simplify. So we're going to rewrite everything in terms of sine and cosine and then simplify it. We've actually done stuff like this before, so this should technically be review for you. But if I say cosecant alpha times tangent alpha, and you wanted to rewrite that, you would say, oh, cosecant is 1 over sine times tangent, which is sine over cosine. The sines will cross out, and I'm left with 1 over cosine alpha. You might be thinking that you could rewrite that as secant, but remember the directions say to express in terms of sine and cosine, then simplify. So leave it in terms of sine and cosine. Let's do one more. And if I said cosine alpha times tangent squared alpha times cosecant squared alpha. Excuse me. So when we go to rewrite this, we're going to leave cosine alone. Cosine alpha times sine squared over cosine squared. And cosecant is 1 over sine, so we have 1 over sine squared alpha. The sine squareds are going to cross out, and I have 1 cosine over a cosine squared, so I can rewrite that here just to show you. But that's actually going to simplify to be, again, just 1 over cosine alpha. How we feeling? Hopefully fantastic, easy peasy right now. So let's move on and let's talk about the first identity that we did. 1. We learned this as sine squared plus cosine squared equals 1. That was theorem 1-1. It's the equation of the unit circle. However you want to remember it, sine squared plus cosine squared equals 1, and it's mega important. From here, you can perform any algebraic manipulation of that, and we could say cosine squared alpha happens to be 1 minus the sine squared. Or you could even say that sine squared alpha equals 1 minus the cosine squared. All those algebraic manipulations of sine squared plus cosine squared equals 1 is possible. Now, if you take sine squared plus cosine squared equals 1, and we're going to divide everything through by cosine squared. What you do on one side, you can do on the other. So we're going to divide by cosine, divide everything through by cosine squared alpha. So we get sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. Simplifying this, we have sine squared over cosine squared, which equals tan squared alpha. Cosine squared over cosine squared is 1, and 1 over cosine squared gives us secant squared. Okay, that's another important identity. We'll call that identity 2. Keeping with this same idea of taking sine squared plus cosine squared equals 1 and dividing everything through by sine squared leaves us now with sine squared over sine squared plus cosine squared over sine squared, and that is 1 over sine squared. Putting this into the other trig forms that we know, we get 1 plus the cotan squared alpha equals the cosecant squared alpha. And say hello to identity number 3. You can algebraically manipulate identities 2 and 3 also. So you could say 1 minus cosecant squared equals cotangent squared, etc. We're not going to write them all out, but just know that you can algebraically manipulate those as well. And while it's good to memorize identity 2 and 3, know that everything is derived from sine squared plus cosine squared equals 1, so you don't have to. Okay, so here we go. Back to that, express in terms of sine and cosine, and simplify. Writing out our directions here. Okay, number 1. Let's go with tan alpha times sine alpha plus cosine alpha. We're going to rewrite it, and we're going to say tangent is sine over cosine times sine plus cosine. Okay, that's going to give us sine squared over cosine plus cosine. How can I simplify and combine these two? Oh, we need to get a common denominator. So in order to get a common denominator, I'm going to multiply this by cosine over cosine, which will give me cosine squared over cosine. That would combine to be sine squared plus cosine squared over cosine. And if you remember from our lovely identities, sine squared plus cosine squared equals 1. So I'm left with 1 over cosine alpha. Let's do another. Okay, but now right here, I want you to show that, that looks horrible. Let's try that again. Show that the left side equals the right side. Dealing with identities, it's a lot of verifying that they are identities and that two things equal each other. So for instance, I could say 1 minus cosine squared beta times 1, that's a plus sign, not a 1. You got a little carried away. 1 plus cotan squared beta equals 1. When you're doing something that to show the left side equals the right side, you can't assume that they're equal. We are essentially proving it. So you can work with one side or the other, but you cannot cross over the equal sign. So, for instance, I'm going to say, okay, 1 minus the cosine squared. Well, if sine squared plus cosine squared equals 1, 1 minus the cosine squared is the equivalent of sine squared beta. Times 1 plus the cotan squared beta. Well, I know that 1 plus the cotan squared equals the cosecant squared beta. Again, we're saying that that equals 1. So we're going to keep going. I have sine squared beta times 1 over sine squared beta. Sine squared over sine squared equals 1. 1 equals 1. Check. We did it. Let's do another one like that. Same direction. Show that the left side equals the right side. 1 plus the tangent squared of alpha over the cosecant squared of alpha tan squared alpha. Now, I put a semicolon here because that's the notation that you can find in your textbook. But really what that just means is 1 plus the tan squared over the cosecant squared equals the tan squared. Okay, Remember, you can't cross over the equal sign. You can work with the left side to make it equal to right. You can work with the right side to make it equal to left. Or you can work with both sides until they are equal, but you cannot cross over. 1 plus the tan squared. That's theorem, not theorem, goodness. That's identity number 2, and that equals the secant squared. Secant squared over cosecant squared. Well, that is 1 over the cosine squared over 1 over the sine squared. That happens to be 1 over cosine squared times sine squared, which equals sine squared over cosine squared, and that does in fact equal tan squared alpha. There we go. Sorry, I ran out of room, so we started going horizontally there. All right. Hopefully we're feeling pretty comfortable with the 3 identities. Let's recap them. Sine squared plus cosine squared equals 1. 1 plus, oh my goodness, I am all over the place with this. Excuse me, guys. 1 plus the tan squared equals the secant squared. And 3, 1 plus the cotan squared equals the cosecant squared. Notice everything is squared, okay? Now, Mr. Bright likes to tell his class that for this one, you have 1 plus the tomato equals the sauce, and 1 plus the cottage equals the cheese. If that helps you to remember it, go for it. If you just want to know that 1 plus the tan squared equals the secant squared, you can go for that too. What I want you to do now is to look in your textbook at page 154 and take a look at numbers 10 through 38 even. In there, you're going to rewrite everything in terms of sine and cosine, and you're going to simplify. In class, we'll do more practice dealing with the left and the right and making them equal. And then you'll be having your quiz in approximately 2 classes. But we'll talk more about that when I see you. Have a good one.